solution stoichiometry. Now, the good news is, if you know gravimetric stoichiometry, if that makes sense to you, and if you know how to do molar concentration calculations, then you already know solution stoichiometry. You just have to put those two things together. So in solution stoich, one of the species, or more than one of the species, is present as an aqueous solution. So as a result, you can't use your molar mass formula, you can't use the ideal gas formula, you have to use the amount concentration formula to figure it out. C equals N over V. Right? The concentration in moles per liter is equal to the number of moles divided by the volume in liters. So what does it look like? What volume of 14.8 mole per liter potassium hydroxide is needed to completely neutralize 1.5 liters of 12.9 mole per liter sulfuric acid? So this is a stoichiometry calculation. That means you have to have a balanced chemical equation to start with. Let's start with that. I have potassium hydroxide is my one reactant. It's reacting with sulfuric acid, H2SO4, aqueous. And a neutralization is just a single replacement. So the potassium and the hydrogen here are going to trade places. The hydrogen ends up with the hydroxide to form water. The potassium ends up with the sulfate to form potassium sulfate. And I can look it up on my periodic table. I know that because potassium is group 1, this guy is going to be aqueous. Now I need to balance it. I can't forget about that step. So if I don't balance it, the stoich isn't going to work. That looks good. Now let's write the information that I have. 14.8 mole per liter potassium hydroxide. So that's my concentration. 14.8 mole per liter. That's all I know about it. And I want to know what volume is needed to completely neutralize 1.5 liters. So that's a volume of 12.9 mole per liter sulfuric acid. So now if I want to figure out the volume here, right, I can think about my concentration formula. If I'm looking for volume, I already know the concentration. The thing that I'm missing is my number of moles. So that's what's going to come out of my stoichiometry. So I have two parts of the formula for the sulfuric acid. I can figure out how many moles of sulfuric acid would be present there, then use my mole ratio to figure out how many moles of potassium hydroxide are required, and then use my C equals N over V formula again to find the volume. So I've got 1, 2, 3 steps. Let's try them. So number 1, I've got my volume, concentration. I'm looking for moles. I need to get N by itself, so we can multiply by V on both sides. N is equal to V times C. My volume was 1.5 liters, and my concentration is 12.9 moles per liter. And that gives me 19.35 moles. Now these are moles of sulfuric acid. So then I need to turn those moles of sulfuric acid, figure out how many moles of potassium hydroxide would be represented there. So my mole ratio is 2 to 1 KOH to sulfuric acid. And this is going to work because my sulfuric acids will cancel out. So I need to then multiply by 2. There'll be twice as many moles of potassium hydroxide required. 38.7 moles of KOH. And then step 3, I can figure out how many liters, what volume is required, using C equals N over V now, because now I know my number of moles, which was the part that I was missing. So I need to get V by itself, and remember it's on the bottom of the fraction, so this one's a little bit tricky. Get it to the top of the fraction, and then we can divide by C. So my volume is equal to my number of moles divided by my concentration. Number of moles being 38.7. And my concentration, 14.8 moles per liter, which gives me 2.61. Now I get 3 significant digits, so 2.61 liters of KOH, potassium hydroxide, are required.